We didn't make
Good. It sounds like some of you are at least a little familiar. Okay, so remember what your goal here is. Up until this point, we have solved these by putting both things on a graph at the same time and looking for what? Where they cross, right? So this is a way to find where they cross without actually having to put them on a graph. Okay, that is our goal. We are finding the coordinate where these two things would intersect without actually having to look at them. Okay, it's like magic. And so for this first method, by the way, this first set of notes is going to be much longer than the second, okay? So I don't want you to feel like, oh my gosh, she's not even done with the first section yet, because the second section goes a lot faster. This first one, we cover a lot of the kind of weird situations that pop up, and then the second one is just, here's the method. Okay, so for substitution, the big thing that you have to keep in mind, the big thing that you have to know is that you have to have one equation solved for one variable. All right, you need to have one equation where either x or y is by itself. Now, you're used to having y by itself, right? You have y by itself when you're in slope-intercept form a lot. But it is okay for you to have x by itself as well. If it's easier for you to get x by itself, do it. And the whole idea rests upon the fact that, like, for example, here, where I say y equals x minus 3. If y is equal to x minus 3, that means they're, like, interchangeable, right? That they're the same value, that y and x minus 3 are the same thing, so I can substitute them and no one would notice, okay, kind of thing. So what I'm going to do is I'm going to take that bottom equation where I have y by itself, and I'm going to take what y is equal to, which is x minus 3, and I'm going to put it in place of y up here, okay? Because this is really saying that y and x minus 3 are the same thing, so I can just put this in place of y and it'll have the same value. And so now that top equation will look like this. 3x plus, but then instead of that y, we're going to have an x minus 3 equals 25. What is the advantage to that? Why do I like that better now? Yeah, I only have one variable. I only have x, so now I can solve for x, okay? So now I'm just going to solve like a regular equation. So 3x plus x is 4x. 4x minus 3 is 25. Add 3 and add 3. 4x equals 28. Divide by 4, divide by 4. X equals 7. Okay. Now, am I done? Why not?
You have to plug in for y.
Okay, because what's my answer going to look like? It needs to be a coordinate, right? Because it's supposed to be the place where they cross. So if I want a coordinate, I need an x and a y. So I'm going to take what x equals. I could technically plug it into either one of these equations, and it would work. But if I'm looking for y, I want to use an equation that says what y equals. All right, that's just going to make my life easier. So I'm going to take x equals 7, plug it in up here, and I'll have y equals 7 minus 3. So that means y equals 4. And then my coordinate would be 7, comma 4. And that would be my final answer. Good with that? Easy? Okay. Look at the second one. How do we start one of these? How do we make sure we're in the right place to start?
Make sure the variable is equal to.
Okay, so I need something by itself. Do I have that here? I actually have 2 of those here, right? I have both of them solved for y. That's okay. You really only need 1, but it's okay. So I'm going to take what y equals down here and plug it in for y up here. Could I have gone the other way?
Yeah.
Sure. I could have gone this 3x down in place of this y also. That's going to give me x plus 4 equals 3x. Then I'm going to minus x and minus x. So I get 4 equals 2x. Divide by 2 and I get x equals 2. Okay. The equation solving part, like from here, I usually fly through pretty quickly because I feel like you guys are pretty good equation solvers. But if I go too fast, please stop me. Okay, and ask me to go back and slow down. All right, now I need to go back and find what y is. Where am I going to put that?
Into the either one.
Yeah, this one actually, either one would be fine, right? I could put it in up here and I'm going to get 6, or I can put it here and I can get 6. Doesn't matter. So if I put it there, I would get y equals 2 plus 4, which is 6. Do you see that I would also get 6 in the top one?
Yeah.
Yes? Okay, so my coordinate here would be 2, 6. Good? Okay, take a minute if you haven't yet and write down 3 and 4, and we'll start those in just a minute. And think about what's different about number 3. What's wrong with number 3?
There's no number so
No y equal.
Okay, there's nothing where either x or y is by itself. Do you see one that would be pretty easy to get by itself, though?
2x.
I would probably say this top one I could get y by itself by just doing what?
Subtracting.
Okay, so it's minus 2x and minus 2x. So I could rewrite this top equation as y equals... now, you're probably used to writing this as negative 2x minus 1, just from when we did slope-intercept form, which is fine. In this method, it actually doesn't matter. I could have written that as negative 1 minus 2x, and that would be fine too. Now I have what y equals, so I can put what y equals down here in place of y. Okay? So I'm going to get negative 3x plus 3. Now be careful here, because you need to take 3 and multiply by all of y. This whole thing is y. So how am I going to show that I'm multiplying 3 by all of this? Good. So parentheses around what you're putting in. And I would use those parentheses anytime there's a number out front here. Equals negative 21. And then how do I start this to solve? Distribute. Yep, distribute the 3. So negative 3x. 3 times negative 2 is negative 6x. And 3 times negative 1 is negative 3. I would put these together. Negative 9x minus 3 equals negative 21. Add 3 and add 3. Negative 9x equals negative 18. Divide by negative 9. X equals 2. Everyone okay with that equation part of that?
Yeah.
Okay. Now, I need to plug back in and find y still. Where would you suggest I do that?
Put it into y equals.
Okay, this equation here isn't one of my originals, but it's really just a rearrangement of one of the other ones I have, right? So I'm allowed to use it. So I'm going to put this 2 into this equation. And just because I don't want to use up my space over here, I'm going to go down here. So y equals negative 2 times 2 minus 1. That's negative 4 minus 1, which is negative 5. So final coordinate, 2, negative 5. Good? All right, one more. That's just a little bit weird. It's really not that bad. Right, right. At the beginning, I already have a y by itself, right, in that next one, so that's good. So y is equal to 8, so that tells me I can put an 8 right down here. So I'm going to have 2x plus 5 times 8 equals 8. That's really 40. So 2x plus 40 equals 8. Subtract 40 from each side, I get 2x equals negative 32. And then divide by 2. Oh, I felt the need to write that out and not that, but x equals negative 16. Okay, normally this is where we would plug back in for y. But I already have y, right? I already know that y is equal to 8, because what this equation is saying is no matter what x is equal to, y has to equal 8. So when x equals negative 16, y is equal to 8. So my coordinate is negative 16 comma 8. Okay, that is just the plain old, plain Jane, straightforward substitution.
I like that
Good. How would you do on a quiz? 1 you would fail, 5 you would ace it. Like if I gave it to you right now. Okay.
Do it right now.